Hello students, so let's continue with the first exercise of real numbers. Okay, so we have done the first question, second question and the fourth question. So let's continue with the fifth one, and the third one is pending. Let's do those. So in the fifth question, so using Euclid's division lemma, we have to show that cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So that is, let's take any integer, any positive integer. If I cube it, either it is in the form of 9m or 9m plus 1 or 9m plus 8. So initial step, let's take a positive integer. Let a be any positive integer. So using Euclid's division lemma, EDL stands for Euclid's division lemma. So what can I write? A as B into Q plus R, where A is dividend, B is divisor, Q is quotient, and R is remainder. Okay. Now, we have to show that cube of any integer is in this form, 9m, 9m plus 1 or 9m plus 8, isn't it? So, what should we take the value of B as? 9, isn't it? That is what we have discussed in the previous problems. But if you take the value of B as 9, then you will get 9 cases, because if you take B as 9, we'll get R value as 0, 1, so on up to 8, not 9, up to 8. So therefore you will have 9 cases, isn't it? So solving all those 9 cases is a bit lengthy and tough also. So what we'll do is, instead of taking the B value as 9, we'll take it as 3. Why 3? Because the question is cube of any positive integer, right? So we'll take 3. If I get cube it, I will get 27, isn't it? 3 cube is 27. That 27 can be written as 9 into 3, isn't it? 27 can be written as 9 into 3. So if I take B as 3, there is a chance of expressing it as in terms of 9. Okay, that is why we are going to take B as 9. Let B is equal to 9. Implies R value will become 0, 1, 2. That's it, isn't it? Sorry, B value is 3. So 0, 1, 2. Okay, therefore A will become, B value is 3. So 3 cube plus R. So case 1, first case, when R is 0. So A will become 3 cube plus 0, which implies A is 3 cube. Now this is my positive integer. Okay. If I cube it, I have to cube it, isn't it? So cubing on both sides. So A cube is equal to 3 cube whole to the power 3. So what do we get here? A cube as A cube itself. A cube itself. 3 cube whole to the power 3 is 27 cube to the power 3. This I can write it as 9 into 3 cube to the power 3. A cube is equal to 9. This 3 cube to the power 3, I'll take it as m, where m is 3 cube to the power 3. So you have got cube of any integer is in this form, 9m. Either it should be 9m or 9m plus 1 or 9m plus 8, any 3. Okay. So we have got one of that. Okay. Now, let's take the case 2. That is when R is equal to 2. So what do we get? A is equal to 3 cube plus 2. Cubing on both sides. So we get A cube is equal to 3 cube plus 2, the whole cube. Sorry, when R is equal to 1, isn't it? The next case. So let's take it as 1. So 3 cube plus 1, the whole cube. So it is A plus B, the whole cube. Or X plus Y, the whole cube. What is X plus Y, the whole cube? X cube. Your X is 3 cube, Y is 1. So X cube plus Y cube, X cube plus Y cube plus 3x square. When I say X, it is 3 cube. When I say Y, it is 1. 3x square Y plus 3x Y square. We got it? So A cube is equal to 9 cube to the power 3. 1 cube is 1. 3. Remember, you cannot multiply this 3 and this 3, because there is a power hanging here. for this 3. So we have to solve that. So 3q whole to the power 2 is 9q square into 1. 3 into 3q, 1 square is 1. We should always solve for the powers first. Okay. Then a cube is equal to 9q to the power 3. I'll write this 1 at the end. Okay. 3 into 9 is 27 q square plus 3 3s are 9q. At the end, let me write 1. From all these three things, I will get, I can take 9 as common. So I'll be left with q to the power 3, 3q square plus q. Outside you've got 1. Replace this entire thing by m. So what do we get? We get a cube is equal to 9. This entire thing is replaced by m plus 1. So when I cube an integer, either it is in this form 9m or it is in this form 9m plus 1. The third one is 9m plus 8. If you take the next case, that is when r is equal to 2, you get a as 3 cube plus 2, cubing on both sides. So you get a cube as, let me do it directly. When you cube this, you get a plus b the whole cube. Same stuff. You'll be getting 9q to the power 3 plus 2 cube is 8 plus, let me do it directly. 4 3s are 12. 12q square plus 2 3s are 6q. Okay, you get it something like this. Let me check it again. Okay, 3a square. I'm sorry, you get 27 into 2, 54q square plus 3 3s are 9, 9 2s are 18q. We get it like this. When you cube it, just try it out using the formula. Send this 8 to that side. So a cube is equal to 9q to the power 3 plus 54q square plus 18q plus 8. From all these things, you can take 9 as common. So left out things, whatever you get, we'll take it as m. What are the left out things? If you take 9 as common, q square, 6q, q cube, 6q square plus 2q plus 8. Take all this stuff as m. So 9m plus 8. So you take any integer, a is some integer. You take any integer that you wish. If you cube it, either it will be in this form, see here, a cube is in this form, or it is in this form, or it is in this form. So that's the question. So take any integer. If you cube it, you should get it in these three forms, and we have got it. Okay. This is the 5th question, students. Let's continue with the next question. The 3rd question, that will be the last question in this exercise, because in the previous video we have already completed the 1st one, 2nd one, and the 4th one. Only the 3rd question and 5th question were pending. So we have finished with 5th one. Now the 3rd question. So an army contingent of 616 members is to march behind an army band members of 32 in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Okay. A very, very simple question, but very tricky question also. Now listen, there are 616 members. Okay. These people who are going to march behind the band people, isn't it? We have observed even in our school, all those stuff, the band people goes in the they go in the front and the others follow them, right? The people who march go behind them, right? So we have got 32 members in the band, and these people are for marching. Okay. Now we have to divide them into some number of columns. I have to divide them. I have to, using these people, I have to make columns, and same thing for this. But the stuff here is we have to make sure that both have same number of columns. Okay. And the column should be also maximum. Okay. Now, a very interesting question. First, let's analyze this. Let's take only this 32, or let's take, forget about this question. Let's take an example. Say, suppose I've got 10 members. Can I make, using this 10 members, can I make 3 columns out of it? Say suppose this is my first column, second column, third column. Okay. Now I'll take one member, I'll put it in first column, another one in second, third. Okay. 1, 2, 3. 1, 2, 3. Okay. The remaining one will come in here, isn't it? So observe, there are 10 members. Randomly we'll select one, we'll put it in the first column, the other one in the second, third. 3 people finished. Then fourth one, fifth one, sixth one, seventh one, eighth one, ninth one, 10th one. Can we form such a kind of column? Think about it. Is it possible? No, because each column should have same number of people. You cannot have something like this, odd one here. Or say suppose, can I make 4 columns? Is it possible to make 4 columns? Okay, if I wish to make 4 columns, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 10 people. I've divided them into 4 columns. But as you can see, the first column has got 3 people in it, second column has got 3 people, but the other two have got only 2 people. You cannot have such a thing, right? You have observed many parades. You might have watched in the television also during the Independence Day or Republic Day. Each column has same number of soldiers or same number of people marching, isn't it? You cannot have such a formation. Now observe, whatever number of columns I wish to choose. See, initially I wanted to make 3 columns. It was not possible. Then I wanted to make 4 columns. It is not possible. Say suppose you want to make 2 columns. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It is possible, right? So I wanted to make 2 columns. Out of 10 members, I wanted to make 2 columns. It is possible. Even if I wanted to make 5 columns, it is possible. Now, if you observe carefully, whatever the number that you choose, you want to make n number of columns, whatever the number of columns that you want to make, that number should be a factor of this. Observe, 3 doesn't divide 10. 4 doesn't divide 10. This 5 divides 10. That is where you were able to make 5 columns. This 2 divides 10. That is where you were able to make 2 columns. So, how much ever column you wish to do it, that number should be a factor of this. Or say, can I make a column of, say suppose I've got 15 members. 15 members. Can I make 4 columns out of it? Can I divide them into 4 columns? Not possible. Why? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Here it is empty. Not possible. We cannot make. Why? Because this 4 doesn't divide 15. Meaning this number is not a factor of 15. So what we are trying to do is, we are trying to divide these people into some columns and these people into some column. Okay. And both the columns should be same. Meaning I have to find the factor of 616 as well as 32. Meaning I have to find a number which divides this and which divides this. At the same time, it should be the maximum. In simple words, I am trying to find a bigger number which divides this and which divides this. Meaning, I have to find HCF. What is HCF? HCF is highest common factor, meaning a highest number which divides both. So here, if I want to make them into some number of columns and this into some number of columns, I have to find the factors. Can I make them into 5 columns? 32 members into 5 columns? Not possible. Try it out, because this 5 doesn't divide 32. So I have to find a number. I have to find a number which is a factor of this. Now, both the number of columns should be same. So I have to find a number x which should be a factor of this as well as factor of this. And this should be the highest number, meaning we have to find the HCF. So using Euclid's division lemma, let's find the HCF of 616 and 32. So let's write down maximum number of columns is equal to HCF of 616, comma 32. So let's find 616 will be your dividend. 32 is your divisor. The smaller one will be the divisor. The bigger one will be the dividend. So let's divide it. 32 ones are 32. 29, 296. So let me assume this as 30 and this is 300. 30 tens are 300. So I have to take one less. 32 nines are. So 32 nines are 9 twos are 18. So you get 288. So you will be left with 8. So 8 is the remainder. That remainder will become the divisor. The earlier divisor will become dividend. 8 fours are 32. You're getting 0. So this is the final step. In the final step, whichever is your divisor, that is the HCF. Therefore, HCF of 616, 32 is 8. Meaning, I have to divide these people into 8 columns and these people into 8 columns. Okay, that is the answer for the given question. I hope you guys have understood. Thank you guys.